Previously, we covered the core foundations. Now in part 3, solar flares explained. What actually happens when the sun erupts? Part 3, the 1859 Carrington Event, when solar flares nearly ended. Imagine telegraph operators receiving electric shocks from their equipment, whilst auroras blazed across skies as far south as the Caribbean. In September 1859, the most powerful solar storm in recorded history turned our planet's magnetic field into chaos for 33 hours straight. Last episode, we explored how modern solar flares disrupt our technology. Today's question: what happens when a truly massive solar storm hits Earth, and could it happen again? The story begins with Richard Carrington, a British astronomer observing the sun from his private observatory in Surrey. On the 1st of September 1859, he was sketching sunspots through his telescope when something extraordinary occurred. Carrington witnessed two brilliant white flashes erupting from a massive sunspot group. He'd just become the first person to observe a solar flare in real time. Within minutes, he realized he'd seen something unprecedented, but he couldn't have predicted what followed. The telegraph network collapses. 18 hours later, the coronal mass ejection from Carrington's flare struck Earth's magnetosphere. The results were immediate and dramatic. Telegraph systems across Europe and North America failed completely. Operators reported receiving powerful electric shocks from their equipment. Telegraph wires sparked, setting fire to telegraph offices in multiple cities. But here's the remarkable part. Some operators discovered they could disconnect their power sources entirely and still send messages using only the electrical current induced by the geomagnetic storm. One operator in Boston successfully maintained communication with Portland, Maine for 2 hours, using nothing but the storm-induced electricity flowing through the wires. Auroras at the Equator. The visual effects were equally extraordinary. Auroras appeared as far south as the Caribbean, Hawaii, and southern Italy. Gold miners in the Rocky Mountains reportedly woke up thinking it was dawn because the aurora was so bright. These weren't the gentle green curtains we associate with northern lights. Witnesses described intense red and white auroras that pulsed and flickered across the entire sky, visible even in broad daylight in some locations. Modern analysis reveals the true scale. Contemporary research using ice core data and magnetic field measurements suggests the Carrington event was approximately 50 times more powerful than the largest solar storm we've experienced since. The geomagnetic disturbance reached levels that would overwhelm our current measurement systems. Scientists estimate the storm's intensity at negative 850 nanotesla on the DST index, a scale where negative 100 already indicates a severe geomagnetic storm. What would happen today? If an identical event struck tomorrow, the consequences would be catastrophic for our electronic civilization. Power grids would face widespread transformer failures. Unlike 1859's simple telegraph networks, our interconnected electrical systems would amplify the damage. Large transformers, which take months to manufacture and replace, could fail across entire continents. GPS satellites would likely suffer permanent damage from the intense radiation. The positioning errors could ground aircraft and disable navigation systems worldwide for months. Internet infrastructure depends on precisely synchronized timing signals from GPS. Without these signals, data centers and communication networks would struggle to maintain coordination across long distances. The inevitability question. Solar physicists consider another Carrington-level event inevitable, not improbable. The Sun follows an 11-year activity cycle, and extreme events like 1859 occur roughly once per century, based on historical records. The difference is that in 1859, human civilization operated with minimal dependence on electrical systems. Today, a 33-hour global blackout would affect banking, water treatment, food distribution, medical equipment, and virtually every aspect of modern life. The Carrington Event demonstrated that space weather represents a genuine threat to technological civilization. Unlike most natural disasters, a severe geomagnetic storm would simultaneously affect multiple continents with little warning. Next episode, Part 4, explores the next key question: how scientists monitor solar activity and whether we can predict the next big one. If this breakdown of history's most powerful space weather event was useful, please subscribe for more grounded science explanations. That is Part 3 of Solar Flares Explained: what actually happens when the sun erupts. In Part 4, we explore the next key question. Subscribe so you do not miss it.